There's no doubt about it, space is a harsh environment. The astronauts on the International Space Station put themselves through a lot, not only the effects on the body of microgravity, but increased rates of radiation, high energy charged particles which can ionize the atoms in their body, causing damage to DNA, mutations which could lead, in the worst cases, to cancer or death. Thankfully, the Earth's magnetic field provides a great deal of protection to most forms of space radiation, though that protection isn't perfect. With the latest expedition of the International Space Station due to return to Earth, and that includes ESA's first British astronaut, Tim Peake, I thought I'd have a look to see what they'd subjected themselves to in terms of radiation over the last 6 months. What you're seeing here is the radiation landscape that the International Space Station was flying through, as measured by NOAA's Polar Orbiting Environment satellites. The inner Van Allen radiation belt is a region of space where protons are bouncing around within Earth's magnetic field. Thankfully, as you get closer and closer to the ground, the magnetic field increases and at some point will reflect those particles back away into space. And in most regions above the Earth, the International Space Station is at a safe altitude. But because the magnetic field is weakened in the South Atlantic anomaly, it allows these charged protons to penetrate to lower altitudes. The other main regions of high radiation you can see are the auroral ovals at both the northern and southern hemispheres. This is where the aurora comes from. High energy electrons which are excited travel down the field lines and hit the Earth's atmosphere. Now, normally the International Space Station is at latitudes low enough so it doesn't actually encounter them most of the times. That is, unless a geomagnetic storm is going on. Earth's magnetic field becomes depleted, it weakens due to magnetic reconnection, and those auroral ovals move to lower latitudes. In fact, you can see that the International Space Station passed over the auroral oval a number of times during a few key magnetic storms over the last expedition. And this is evident in the graph, whereas normally the rise is fairly linear, there are a couple of jumps up when this occurred. So what are the results? Well, the total energy each astronaut would have been exposed to is the equivalent of a fatal dose of X-rays, around 300 joules. Though thankfully, this would have been spread out over 6 months, and of course, the actual dosage they received would have been much less because they were inside the shielded International Space Station for most of the time. But studying the effects of space radiation on the body is a very important thing, and it's one of the experiments that we're doing by having astronauts up there all the time. Because if we want to go further, if we want to go out into space longer, we need to understand how dramatic space radiation would be on any potential astronauts that we would send on these missions. Thank you so much for watching this video. Please do remember that you can subscribe to my channel to check out more physics and space stuff. And of course, you can share this video with your friends on social media. And please do give me a like if you did like it. All right, thank you.